Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are currently watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve 60 in your KCET 2025 exam in physics. And if you are following our entire series, you already know that we have already completed all the chapters of second PU. Currently we are revising chapters from your first PU, and today we are going to revise laws of motion. But before that, one important announcement that in the weekend, all the Sundays, we are currently conducting KCET Premier League for all the subjects, physics, chemistry and maths. For that, only one thing that you have to do, you have to join our WhatsApp channel. The link is given in the description. Once you join our WhatsApp channel, you will be able to get the question paper every Sunday. Just download it, try to solve it during the day, any time of your choosing, and then in the evening I will be back with the solution. All the teachers will be back with the solution of their respective question papers. So if you have not yet joined our WhatsApp channel, don't forget to join our WhatsApp channel. Now let's start with today's topic, laws of motion. Let us look into the list of contents. First we will discuss obviously laws of motion, and remember that this discussion is only focused towards your KCET exam. We are not going to discuss each and every concept from this chapter. Okay, if you want that chapter complete revision, go open your NCERT book, read from there, and that is the best way to revise. But otherwise, if you want to focus only on KCET, then this is a perfect video for you. Okay, next we are going to discuss about equilibrium, then we will discuss about friction, very important, then we will discuss circular motion. Circular motion we have discussed briefly in motion in a plane, but here we are going to discuss about forces. Centripetal acceleration only was discussed. Centripetal forces were omitted because that was not part of that chapter. Now we will discuss everything here. Next we will discuss about lift motion. Some questions based on lift motion is coming, also falling object and lift motion, okay, motion of a lift. And then we will discuss one general problem based on, we call it mechanics problem. So we will be going to discuss everything today. So let's start with laws of motion. So Newton's first law of motion, we already know Newton's first law of motion. So what is the statement? Everybody continues to be in the state of rest or uniform motion in a straight line unless compelled by some external force to act otherwise. Okay, so everyone is always moving in a straight line or in the state of rest, okay, unless some external force is acting on it. So for example, if I leave you as it is, okay, you will continue to play PUBG or continue to watch reels, unless and until your father or your mother or some teacher will come and scold you. Okay, what are you doing? Why are you wasting your time? Right? So Newton's first law of motion for Gen Z is either play PUBG, continue to play PUBG, or continue to watch reels. Right? So just joking. So I hope you understand that this is not time to waste, okay, by playing PUBG or watching reels. So you have to put more attention in your studies. Right? Now, so this is the first law statement. Okay, if nothing happens, no force acts on the object, then this object will either move in a continuous motion or it will be at the state of rest. Right? So this is the basic 2 points about first law of motion. Now let's move into the second law. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So in the first law, the force is defined. Okay, force is basically the external cause that makes an object move or change the state of motion. Okay, so that is the force. Now what is second law? Second law states that the rate of change of momentum. So when you apply force on an object, its momentum will change. Okay, so its momentum will change, and that change in momentum is basically proportional to the applied force. Right? So when you apply force to an object, its momentum will change, and that momentum will be proportional to applied force. Right? So and the momentum will change in the direction of applied force. okay, and we always know the famous equation F equals to ma. Okay, I like to call it father equal to ma. Okay, father and mother both are equally important, that's why I always say father equal to ma. So the way you can remember that is fine, but it is inspiring for me. This equation is the very first equation that is important from this chapter. Now let's move on to the problem. An object with mass, so this is the questions will not be straightforward from this chapter, okay, they will, and only numerical questions are coming from this chapter. There is no concept based, concept related questions so far in last 10 years came from this chapter, only numerical questions that are coming from this chapter. So you have to apply one or other concept from this chapter to solve this question. So for example, let's take this example. Okay, an object with mass 5 kg is acted upon by a force F equals to minus 3I plus 4j Newton. Okay, so force is given. Its initial velocity at t equals to 0 is 6I minus 12j meter per second. The time which it will just have a velocity along y-axis is. So basically, what is the meaning of that? So if you see, there are force, the force has two components. One is along x-axis, one is along y-axis. Okay, and then the velocity will also has two components. Initial velocity, it has two components. One is along x-axis, another one is along y-axis, including the sign. Okay, so the question says that at what time the object will have velocity only along y-axis. Okay, so that means its x velocity will be 0. Okay, so its x velocity will be 0, and the j component we will not even consider to solve this problem. Only thing is to understand this question. The question says that when there will be only y velocity remains, that means x velocity has to be 0. So we have to start with what is the force acting on the x axis. So fx is equals to minus 3. Right, so the force acting along the x-axis is minus 3 Newton. Okay, so what is the acceleration? Acceleration is force, acceleration along x-axis is force divided by mass. So minus 3 divided by 5 is the acceleration. What is the component of initial component of velocity along x-axis? Ux. Ux, you can see it is 6. Okay. Now we have to find the time where its final velocity along x-axis is 0. Okay, so now the problem is simpler. Okay, the language of the question seems difficult, but if you read and understand this question, it is simply a motion in a straight line problem, but they have asked in a different way. Okay, so first of all, only second law is applied here. So you have calculated the acceleration. Now you know that final velocity will be 0, initial velocity was ux. Okay, and at. Okay, v is equal to u plus at, that is the formula. So v is 0. So 0 equals to 6 minus 3 by 5 t. Okay, or t equals to 6 into 5 by 3. So it will be 2. So 10 seconds. After 10 seconds, its velocity along x-axis will be 0. That is, only y component will be left. Okay, so basically they can ask you that same question, that at what time the velocity along x-axis will be 0. Okay, so this is the problem. This is how you tackle this kind of problem. So the problem may appear difficult, but if you think and use your head a little bit, then you can solve these questions. And to be prepared for this question, you have to solve such similar questions again and again to get complete value of such questions. So for that you have to attempt our weekly mock test. We are doing similar questions every time from your previous year. Sometimes we are directly giving the previous year questions, sometimes we are changing the values and giving the previous year questions. Okay, so this type of patterned questions are very important to solve, and this is from KCET 2019. Now let's move on to the third law of motion. The third law of motion, the easiest law, that is, to every action there is always an equal and opposite reaction. Now remember that there is no starting point. This is action, this is reaction. That was not defined in Newton's law. Any force, whenever you are applying a force, there is an opposite reaction, but there is no kind of cause and effect relation. Anything can be cause, anything can be effect. Okay, so cause and effect was not properly defined, but generally when we say that action generally means when something is externally applied force. Okay, so when you apply external force, the system responds with a reply. That reply is equal and opposite force, but for action and reaction does not act on the same object. Right, we know that. So for example, if we push this board backwards, if I push this board, the board will try to push me back as well, but the force that I apply is working on the board, and the force that board applies acting on my hand. Okay, so these are two different objects. So there is a question why action reaction pair cannot create equilibrium. Okay, because they act on the different objects. So that is a basic concept. Okay, this is a conceptual thing, and I have not seen any questions related to third law. So third law just a conceptual thing, but without third law, the laws of motion chapter is incomplete. Okay, so now let's look into the next part, equilibrium. Okay, what is the meaning of equilibrium? Very important concept. Okay, so equilibrium of a particle in a mechanics refers to the situation when the net external force on the particle is 0. So if I say this object is in equilibrium, so equilibrium means, okay, equilibrium means first of all it is not static condition. First of all, you have to understand. Okay, but net force in the object acting on the object is 0. That means acceleration is 0, but velocity may not be 0. Okay, for example, if an object moving with a constant velocity, it is in equilibrium. Okay, because it is not accelerating. That means whatever force is acting on that object, there is a equal and opposite force present in the system as well. For example, if I apply a force in this direction, there is a force from this direction, there is a force from this direction, there is a force from this direction. Okay, all the sum of the forces will be 0. Now, while considering the forces, we generally consider that vertical forces or any force in any other direction, any force in any other direction, we have to take it to the components. Okay, so one is along horizontal direction, one is along vertical direction. So if we find all the components along vertical and horizontal direction, and if we individually add them along horizontal, okay, the resultant should be 0. Similarly, all the forces acting along the vertical direction, if you add them up, that will also be 0. Okay, so vertical forces and horizontal forces individually are 0. Okay, that is one concept that you have to remember while solving problems. Okay, I hope you know that. Okay, because this is y axis, this is x axis, right? So horizontal axis is x axis, vertical axis is y axis. Individually, since they are perpendicular to each other, they are independent of each other. So we generally we take them independent, and independently we calculate them to be 0, right? Now, very important concept, friction. We will apply the concept of equilibrium while solving problems related to friction. What is friction? There are two types of friction. One is static friction. Okay, static friction means it opposes impending motion. What is the meaning of this term, impending? Okay, what is the meaning of impending? Impending means the motion, impending motion means motion that would have take place. Okay, it is not actually moving, but it would have take place, but not actually taken place under the applied force if friction were absent. So for example, you have a book on your table. Okay, you have a book on your table, or you are trying to move. Suppose you have a stone. Don't forget about book. You have a huge stone. You want to push the stone. Okay, but the stone is not moving, right? So why it is not moving? Because the force of friction acting on the stone is very high. That's why it is not, you are not able to move that stone. Now, if there was no friction present, somehow you made the ground smooth and the stone smooth so that there is no friction, then if you apply the force, would the stone have moved? Right? Stone would have moved, right? So, but because of the friction, this is not moving. So what friction is that? That friction is called static friction. When the object is not moving, but you are applying external force to make it try to move. Now friction, static friction is a little complex concept, that it changes with the applied force, okay. Up to certain level of applied force, this static friction increases. After it reaches the threshold value, the static friction becomes kinetic friction and becomes constant. So these are the things, okay. But for now, for KCET, you just need to remember that static friction is when object is in rest, okay. When the object is in motion, then it is about kinetic friction, okay. Kinetic friction is the force of friction when the object is moving. Now what is that? This is the coefficient of static friction, mu s. This is coefficient of kinetic friction, mu k. Okay, sometimes they are just stated like static friction, sometimes they are just stated like kinetic friction. Now you have to remember that kinetic friction is always less than static friction. So kinetic frictional force Fk is always less than static frictional force Fs. Okay. Now how we calculate friction? Suppose there is an object, okay. So there is an object and it is, you are trying to make it move, suppose in this direction, okay. So when the object is on a flat ground, suppose, so there is a weight of the object, right, mg, okay. And because the object is exerting a force on the ground, by Newton's third law there will be a reaction force on the object itself, okay. This force is acting on the ground by the object, and this is the force that is being acting on the object by external by the ground. This is generally we call it normal force, okay. So this normal force, if this is n, then the force static the frictional force is given by coefficient of friction times normal, okay. This is the maximum value of the friction force that can act on the object, okay. For static friction generally this is Fs, and for kinetic friction this is if you are writing Fs, this Fs is equal to mu s n, and for kinetic friction Fk it is mu k n, okay. Now this normal force will not be always equals to mg, depending upon the configuration of the system. If it is an inclined plane, we have to take the component of mg. If it is a flat surface, you can take mg, okay. So we will see some problem as well, where we will be solving problems related to friction. Friction is very important concept for KCET exam, okay. So basically you need to remember that kinetic friction is always less than static friction, okay. Now let's look into this problem. A block of certain mass is placed on a rough inclined plane. So suppose the mass of the object is m. Now it is placed in an inclined plane. The angle between the plane and the horizontal is 30 degrees. So this angle is 30 degrees, okay. This is given, okay. The angle between the plane and the horizontal is 30 degrees. The coefficients of static and kinetic friction between the blocks and the inclined plane are 0.6 and 0.5 respectively. Then the magnitude of the acceleration of the block, take g equals to 10 meter per second square. Now this problem can be solved in two ways. One is longer way, one is shorter way. We will see both the ways. Shorter way is not so short because you have to remember the value. Otherwise, what is the longer way? First of all, you have to break this into components, okay. So how can you break this into components? So suppose, let me use some color which is visible. So this is the weight which is acting downward, mg, mass of the block is m, okay. Now this mg will have two components, okay. One component is along this direction, okay. So this is the component. If this angle is mg, this will be theta, that is theta equals to theta, okay. So it will be mg cos theta, okay. Now there will be a component, the reaction component n, which is equals to this mg cos theta, okay. And there will be a component along this direction, this will be of mg sin theta. If you remember, yesterday I said what I think day before yesterday, that if this angle is theta, then the adjacent component is cos theta component and the perpendicular component is sin theta component. right? Now there will be a force of friction acting between the plates, force of friction here, okay, force of friction. Now you have to calculate the acceleration, net acceleration. For that, what we have to do, first we have to calculate the component along this direction, okay. What is the component along this direction? Okay, so along the plane, component of the weight along the incline, I am saying Fi, so it will be mg sin theta. So m times g is 10 sin 30. What is the value of sin 30 degrees? Sin 30 is nothing but half. So m times 10 by plus half, that is equal to 5m. Okay, so this is the force along the direction of inclined plane. Now what is the force of friction? Force of friction, we know that force of friction will be this N times, force of friction will be N times mu k, mu s, okay, because at this point we are assuming this is at rest, okay. So now let's continue that. What was n was equals to mg cos theta, okay, and mu s was 0.6. So what is the static frictional force? Static frictional force is mg cos theta times mu s, that is m times g times cos theta is root 3 by 2 times mu s is 0.6, okay. So it will be 5 6 30, so it will be 3 root 3 m, okay. Now if you calculate root 3 is 1.7 approximately, okay. So if you see 1.7 times 3, it will be 3 to the 21, 21 in hand we have 2, 3 1 the 3, 5. So 5.1 m, okay. So this is the static frictional force. Now if you remember that in the previous part, what we have calculated, the force along the incline is 5m and force of friction is 5.1 m. So force of friction is more than that of the driving force, right. So this is actually so we can write that force of friction is more than that of the driving force, that is along the inclined plane. So the force that is actually trying to move it, the force of friction is trying to oppose that, okay. So that's why the object will not move. In this case object will not move, so acceleration will be 0, okay. So acceleration will be 0. Now this is the long method, but this is a sure shot method, okay. There is a shortcut trick that what you have to do, you have to find the value of tan theta. Theta is given here is 30 degrees. This is the shortcut different method, 30 degrees. Now see what is the value of tan theta. Tan theta is tan 30 degrees, okay. Tan 30 degrees equals to 1 by root 3. Tan 30 degrees 1 by root 3. Now if you calculate this, you will get this value to be equals to 0.57, okay. This is difficult to calculate, but if you calculator are not allowed, but if you somehow able to calculate this, you will see that the value of tan theta is 0.57, which is actually less than that of the static friction. Static friction is equals to 0.6, okay. If the value of tan theta is less than that of the static friction, the object will not move. This is a theorem, okay. That theorem is not part of a syllabus anyway, but there is a theorem that states that if the angle is angle of incline is such that tan theta, value of tan theta is less than that of the static friction, the object will not move. If the angle is such that tan theta, value of tan theta is more than that of the static friction, the object will move, okay. So object will not move, so acceleration will be 0 in this case. Very interesting question, okay. After solving everything, you get the answer as 0. Okay, if in case you calculated everything and you found that mg sin theta is more than that of friction, then what will be the acceleration? So acceleration will be in that case Fi, that is mg sin theta component, minus force of friction. Okay, now in that case you have to calculate the kinetic friction, okay, not the static friction. The object is moving. First you have to check if the static friction is more or not. That is the role of static friction. Static friction does not play any role when the object is moving, okay, but it plays a role to determine whether the object will move or not. It is little complicated if you have not studied this part in your first PU, that what is the role of static friction, what is the role of kinetic friction. Okay, so I am trying to explain it once more. So static friction only helps you to check whether the object will move or not. That's it. If the static friction is less, the object will move. Okay, if the static friction is more, the object will not move. Okay, that is why the tan theta trick that I taught you is helpful if such a similar question comes in your KCET exam. Okay, and this question is from KCET 2024, I think. Okay, now if the object is moving, okay, then you have to only consider the kinetic friction. Okay, so in that case you have to use the same formula, but instead of calculating static friction you have to calculate the kinetic friction as well, and then you have to subtract them and divide it by m. Okay, so most students think that, okay, I will use shortcut. Okay, instead of calculating static friction at all, I will directly calculate the kinetic friction and use this formula. Okay, but that will be wrong, because static friction will never be that level where the object starts moving. So if the object does not move, then how can you apply the concept of kinetic friction? Okay, this is only when if you have checked that this force is more than that of static frictional force, then only this is valid. Otherwise this is not valid. This is how you calculate the acceleration. Okay, so I hope this is a very brief problem of friction. Okay, we will solve few more problems on friction when we are solving the entire PYQs. Okay, if you want more such problems, let me know in the comment. I will try to address more such problems in future videos. Okay, now let's look into circular motion. What is circular motion? Circular motion, basically we have already discussed. Then now when our object is moving in a circle such that its acceleration is perpendicular to the velocity, okay, the angle between acceleration and velocity is 90 degrees, then that is a circular motion, uniform circular motion. And what is the equation for centripetal force? So here that was acceleration. If you remember, it was acceleration. What is centripetal force now? Centripetal force can be represented by mv square by r. Okay, so this is the basic formula for centripetal force. Centripetal force generally being provided by some forces such as gravitational force. Centripetal force generally provided by electrostatic force. It is not an indigenous force. If an object is moving in a circle, okay, circular motion, uniform circular motion, some other force has to provide the centripetal force required to keep it in that circle. Centripetal force is a required force. Okay, it is not like something like electrostatic force. When there are two charges, they will repel them, right? Or there are two masses, they will attract them. It is not like that. Okay, so for example, if you tie a stone on a string, and if you rotate the string, then the stone will rotate in a circular motion, right? Now in this case, what is happening? You are providing the centripetal force by tying the string, okay, and providing the tension to the string. As long as there is a tension on the string will continue to rotate. Okay, so you are basically providing the centripetal force required in this case. You have to remember that. But whenever there is a circular motion, one or another, someone has to provide the centripetal force. So for example, if you are taking a turn in a road, okay, then in that case frictional force between the tire and the ground is providing the centripetal force. Okay, now angular velocity and linear velocity. When the object is moving, there is a another vector quantity that is called angular velocity. It is given by omega, right? I hope you remember that this is the angular velocity. What is the relationship between them? V equals to r omega. Okay, now if you put this equation back here, then you can write centripetal force as m omega square r. Okay, this is another form of centripetal force, very important form. What else? Maximum speed on a curved road. So the example I gave you, if you are taking a turn on a curved road, okay, on a friction wala curved road, then what is the maximum speed with which you can take the turn so that you don't slip? Okay, so the formula for that is given by the maximum speed is square root of mu r g. Okay, mu is the coefficient of friction, okay, r is the, suppose you are rotating like this, there is a curvature of the road can be, if you extend the road, it will be a circle. So circle means there will be a radius of the road, so that is the radius of the road. Okay, so you are only taking turn here, okay, but if you complete the circle, okay, there will be a radius. It is a part of a circle. Any curve can be part of a circle, so there is a radius of that road, so that is the radius, and g is gravitational acceleration. This is the maximum speed with which you can take a turn. So basically, if you driving on a road, okay, or if you are sitting on a car and you are seeing that there is a road, there is a speed limit mentioned in the road, especially when there is a sharp bend ahead. Okay, so in the sharp bend, if you are moving more than that speed, there is a high chance, high probability there will be an accident. So in future, when you get the driving license and drive carefully, drive safely, okay, don't exceed the speed limit, especially when there is a bank, okay, there is a curve, okay, if you cross it, there is a high chance of accident and loss of life and other things. Okay, now let's look into a problem. A person is driving a vehicle at uniform speed of 5 meter per second. Okay, on a level curved track of radius 5 meter. The coefficient of static friction between tires and the road is 0.1. Okay, will the person slip while taking the turn with the same speed? Take g is equal to 10 meter per second square. Choose the correct statement. Okay, these are the statement. So what you have to do, first of all, you have to find the maximum possible speed for that car. So what is the maximum possible speed with which it can take safe turn? Okay, we know that maximum possible speed is given by mu r g. Simple formula. If it is one line formula, okay, there is a complex formula, but I have not seen a single problem based on that formula in KCET. This formula is easier and a lot of questions coming from this formula. So let's see what is mu. Mu is 0.1. Okay, what is r? R is 5 meter, right? And what is the g? G is 10. G is 10. Okay, so if you calculate this, then you will get that this is equals to square root of 5. 0.1 and 10 will cancel. So 0.1 is basically 1 by 10. So 1 by 10 times 10 it will cancel. So V max is equals to square root of 5. So V max square equals to 5. Okay. So if the velocity exceeds this limit, that is V max square exceeds 5. Okay, if V max square exceeds 5, definitely there will be an accident. So in this case, V max square, if you take the square of this velocity, it is 25. So basically there will be definitely an accident. So what is the condition? That if V square is more than 5 meter per second, the person will slip. The person will slip. This is the maximum possible value, right? This is the maximum possible value. If the value exceeds this limit, then there will be definitely an accident. Okay, so the person will slip if V square is greater than 5. Now it is not meter per second, it should be meter square second to the power minus 2. Okay, there is a printing mistake there. because you are doing the square of that. So, if you take the square root, then it will be meter per second. Okay. So, in this case, if v square exceeds the value limit 5, then there will be an accident. Okay, the person will slip if v square is greater than 5. So, be careful. Okay, this is a question from your previous year. Now, lift motion, very interesting and important thing. Okay, so what happens in the lift? First, let us understand. You are a person standing in a lift. Okay, so your weight is acting downward. Instead of representing a human, let me represent a box, that will be easier. So, basically you are a box standing on the lift. Okay. So, you are a box and it is your weight is mg, and there is a reaction force in this direction that normally lift is at rest, v equals to 0, n equals to mg. So, you feel your entire weight as mg. Okay. Now, what will happen if the lift is accelerating upward? The lift is case number 1. Lift is accelerating upward with an acceleration of a. What will happen? Okay. In this case, the lift is moving upward with an acceleration of a. Okay, and your mass say m, this is mg. Okay. Now, in this case, it is easy to remember. How can you remember? So, there is a trick. So, this is a, you can say this is a multi-body problem where you have to find the acceleration. You can apply this concept for tension related problems as well. Okay. So, what is that? You have to remember that this n is in the direction of acceleration. Okay. So, whoever has the direction of acceleration, this person is very rich. If you have the support of acceleration, I am a force and acceleration is also in my direction, then I am rich. Okay. And this person is poor. Okay. So, because the acceleration is in the opposite direction, this is poor. Okay. One of my teacher used to say, this is Amir and Garib. This is Amir, this is Garib. Okay. So, subtract Garib from Amir. Okay. Subtract poor from rich. If you minus poor from rich, then you will get the Newton's second law, ma. Okay. So, n minus mg, because it is accelerating upward, n minus mg equals to ma, or n equals to mg plus ma. You can apply this concept to any of the values if this is a spring balance problem or any other problem. As long as you are applying it correctly, you can calculate this. So, now this reaction force is more. So, what will happen? If the lift accelerates upwards, you will feel heavier. So, if you are someone who is moving in a lift every day, okay, maybe to in your college, maybe in your home, okay, or maybe somewhere else, if you are moving in a lift, maybe in a shopping mall, okay, and if you are moving upwards, you will see that you will feel heavier, slightly heavier than normal, right? Now, longer the lift, faster the acceleration, faster, more heavier you will feel, right? Now, when the lift is moving, now case number 2, lift is case number 2, the lift is moving downward, okay, downward with an acceleration a. Okay, very interesting question. Okay, so in this case, mg is here, normal component is here, and it is moving in this direction. Now, who is rich in this case? Obviously, mg is rich in this case because acceleration is in the direction of mg. So, what we will do? Mg minus n equals to acceleration, ma. So, we can write that n equals to, n will go to that side, ma will come this side, become a negative. So, mg minus ma. Okay. So, when the lift is moving downward with an accelerated motion, you will feel lighter. Okay, you will feel slightly lighter. Okay, and if you have ever been to a merry-go-round in a fair, okay, during different festivals, okay, you feel a lot lighter when the merry-go-round comes down. Okay, that is the main thrill of merry-go-round. Those who have ever tested that thing, they will know that it is very interesting and it is very nerve-wracking. Okay, some people cannot handle that thing, and some people enjoy it, like me, I enjoy that thing. But that is because when you are accelerating downward, your weight decreases because of this reactionary force. Okay, so because of this reactionary force decreases, and you feel lighter. Okay, but when it goes up, you feel heavier. Okay, both are true. Now what will happen if the lift that you are riding snaps from the top? That is, someone do the sabotage and they cut the rope, and it is in a free fall. Okay, so I hope hope to the God, pray to the God that does not happen to you anytime, obviously. But what will happen in a hypothetical situation if this wire snaps and you are standing in the lift? So in that case, you will see that the free fall acceleration of the lift will be equals to g. Okay, so in that case, A equals to g, and the reaction force will be equals to mg minus mg, and it will be 0. So you will feel weightless. Okay, so basically this is the statement that when an object is falling freely, it feels weightless. Okay, because there is no reaction force to give it the sense of weight, so it will feel weightless. So whenever object is falling freely, it will be weightless. Okay, interesting question, right? Now, general problem. Let me solve one general problem. I will solve the problem related to lift motion, upward, downward, accelerated motion in our PYQ section. But before that, let's solve one general problem. This will be the last problem of today's discussion. A mass of 6 kg is suspended by a rope of length 2 meter from a ceiling. Okay, so mass of 6 kg, okay, is suspended by a rope of length 2 meters from the ceiling. So it is 6 kg. Okay, force of 50 Newton in the horizontal direction. So in the horizontal direction, not in the vertical direction. So basically we hang it from this side. Okay, now what we are doing, we are applying a force in the horizontal direction of 50 Newton. Okay, is applied at the midpoint of the rope. Okay, at the midpoint of the rope. The angle made by the rope with the vertical in equilibrium is. So once we apply 50 Newton force here, what will happen? First let us understand that. So when you apply the 50 Newton force here, the rope will be bending like this, but the mass will still be hanging like this, because rope can bend. So you have applied 50 Newton force here, and the mass will be hanging like this. Okay, 6 kg. This length is 1 meter. Length is not very important here. Okay, this is just giving you for some information. So you have applied 50 Newton force here, and they have asked you what is the angle made by the rope with the vertical. Okay, so what is the angle made by the rope with the vertical? So that means you want to find this angle. This angle. Okay, what is the angle made by the rope with the vertical? Now, or you can say this angle. This angle is also theta. Okay, these are alternate angles. So whatever angle you can consider, this angle is easier for me to consider because this will help me to draw the diagram. Now this is something related, something is called free body diagram. Okay, so free body diagram is where we see all the forces acting here and we draw the corresponding forces. For example, let's see the point P. So suppose this is the point P where we have applied this external force 50 Newton. Now what are all the forces here? So first force is this force, okay. This is called the tension of the rope, okay. There is a tension here as well, okay. Here at this point, okay, there will be a tension in this direction as well, tension in this direction as well. Okay. Now, here also there will be a force. What is that force? Mg. Okay. So, mg force is acting downward, there is a tension force acting upward. The object is in equilibrium. That means from there we can write that the tension force is equals to mg, right. So, the tension force is equals to mg. Now, this same tension by reaction force is acting downward, okay, and there is no other force to balance. So, this will also be tension force T here, okay. Now, if you consider this T, then someone has to, let me read out this diagram like this, where 50 Newton is acting at the midpoint. So, I have drawn it in the direction of the force. Now, suppose this is the tension, okay, this is the tension at this point. Now, this tension will have two components. What are those two components? One will be the vertical component T cos theta, another will be in the horizontal direction T sin theta, okay. So, this is incorrect. Now, what we will do, okay, if you see, suppose at this point that reactionary force is N, okay, then the same reactionary force will be acting here as well, okay. Or you can say that T cos theta, so you can write that T cos theta equals to N, okay. You can ignore the thing entirely, you can ignore this N entirely also, you can say that T cos theta equals to mg, okay, because this is the upward force, this is the downward force, right. So, what we will do, we will simply add this as mg, okay. So, T cos theta equals to mg. Now, what is T sin theta? T sin theta is acting in this direction, which is actually balancing the 50 Newton force. So, T sin theta equals to 50, right. Now, remember that in this case you are only supposed to find the angle, so you don't need to do anything complicated. What we will do, we will simply divide T sin theta by T cos theta, okay. Now, T sin theta is 50, T cos theta is mg, mg means m is 6 kg and g is 10 meter per second. So, it will be 5 by 6. So, tan theta equals to 5 by 6. Now, if you have the use of calculator, you can calculate the angle and find the value of theta. If you use the calculator to find the value of theta, then theta will be almost approximately equals to 40 degrees. Okay, this is exact, this value problem will not come, this is a little older version of the problem, but this is a very interesting question, interesting problem where you are applying all the equilibrium condition, all the condition of forces, and then you are trying to find at what angle it will be 0, right. Now, if you have liked this video, don't forget to share with your friends, okay. I will be back with the PYQs of this chapter tomorrow. Till then, bye bye.